kind of open it up and see if people have questions, comments, issues they want to talk about. I can kick some things off if there aren't any, but let's try that approach. See from some of the things that you've heard, either in the earlier talk or the ones that these great folks just gave. If people have issues that they'd like to talk a little bit more about, we've got about 40 minutes here for discussion. Yes, please.
So you had, Mike, I'll try you. Showed kind of a global map of estimated noise. Did you guys actually try looking at any direct measurements and see how your model compared?
Yeah, it's interesting. I was wondering when someone was going to ask that question. One thing.
Can you hear the back? Okay.
We can hear the question.
Okay.
Okay. Well, I can repeat the question. The question was whether we have data basically to validate the modeling results. Yeah, and I guess before I answer that, I'd like to say, I think that the key thing for this is to get people thinking about this process, but I should have probably added a whole series of disclaimers about this. And first of all, this is a hugely complicated modeling effort, and I think really people have to think that, we hope that internationally people will commit to this type of thing, and we're seeing a little bit of that motion. The European Union has made an edict to start looking at noise as a form of pollution. So a lot of people locally are looking at this, but we all have to recognize, I think, that there's a huge effort. It's going to be 20 years before we feel that we really have understood all this. So that's kind of footnotes about, be careful about the modeling results. However, we actually have a task right now where we're supposed to look at model data comparisons more, and I'm not sure how successful we'll be. We have a beautiful comparison for the North Pacific that Rex Andrew helped us get, and it's based on Navy SOSUS data. So these are hydrophone surveillance systems that they were about to pull the plug on, but they didn't, and now the Navy has become sensitive about it. Anyway, we were able to get the data and plot it and overlay it against our maps. We just had the data for the Pacific, actually, and I was a little bit nervous about what that would look like, but it did come out quite nicely, which means that I would say the largest errors across all the frequencies and all the surveillance systems were probably about 6 dB. So we were quite satisfied with that. Unfortunately, we haven't gotten permission to publish that. And I'm not sure at this point that we will get that. We are working, well, we've been working with Megan, she showed you some of her data comparisons, and we've also been in touch with Chris Clark, Paul, and actually John Hildebrand. These are people that have both been deploying a lot of systems, not just in local areas, but really pretty much on a global scale. So that's work we're planning to do.
Maybe I'll just add one thing too. I gave the website in the talk that I gave, the set sound. If you put like NOAA sound mapping working group, it'll pop up the website. And some of the methods are detailed a little bit more. We also have some sort of caveats about, this is what, along the lines of what Mike was saying, here's things that this can do, and here are some assumptions and limitations and stuff like that. But if you go into that, you can see there's libraries of these different depth and frequency cuts, as well as more details on the methods. Okay, other issues? Yeah.
Have you thought about using machine learning techniques to take those errors, feed them back into your models, and then to learn from and propagate those through?
Not specifically, I guess, what you would call machine learning, if I understand what that means. But there is a whole community of people in underwater acoustics that they describe themselves as geoacoustic inverters, or people that do geoacoustic inversion, and they do the same type of thing that is also done in the seismic industry, where they'll go through and make measurements, controlled measurements, where you have a source and a set of receivers over different ranges, and then you go in and you start tweaking bottom parameters and so forth to to try and invert for what that is. And the U.S. Navy also does this routinely, and that's where a lot of that data that you see for the ocean bottom type, that's where that stuff comes from. So you could say that it comes from machine learning. But I'm just thinking, as you raise that, another thing that we've been thinking about is that you could just from, rather than having controlled sources, you could actually use all of that shipping data and kind of use that to back out information about the bottom as well. And so that hasn't been done to my knowledge, but it's something we've been thinking about, and there are some other groups at Scripps, for instance, that have been thinking about that.
Yeah. If I could take just a moment to kind of set the stage. I'm wondering why it is that, for example, the cetacea are good at detecting and localizing sounds, and the ships are fairly loud. How it is that they would be struck, and what there might be some thoughts on that. And then, actually, my friend Mike raised an issue. But, you have these electric cars now, and people are talking about putting some kind of sound, installing sound in them so people can hear them. So let's say we have shipping that's becoming quieter, and then in the future, for example, if we do have quieter ships, let's say, how would some kind of sound be produced from those ships, perhaps to warn whales or other animals in the water column to move out of the way? And even given that shipping is loud today and they're getting struck, how does that work itself out, I suppose? Are there any thoughts on that?
Well, I'll say something briefly, and then maybe Megan can add. We also have John Kalmakidis in the room, who's thought a lot about some of these ship strike issues. I know, since in 2004, there was the first of two workshops that NOAA had on ship noise, and the second one was really specifically on quieting technology. And this interaction between vessel quieting and ship strike probability or risk, and people that have kind of been advocates for alarms is a part of the noise discussion. I think that's why it sort of came up in this, that there's some overlaps between these two things. And, people will point out that for some of the big ships, the kind of shadowing that you get from the vessel itself, as well as the sort of near surface Lloyd mirror kind of things, may mean that an animal right in front of a large vessel near the surface may actually not really get much noise from the ship itself. And that's one of the arguments people make that kind of advocate for alarms. On the flip side, there is the issue of habituation. You put alarms on thousands of ships running around, and pretty soon are the animals really going to avoid them because of the habituation issues. And I tend to be a little more kind of along the lines of that second argument. But maybe I'll throw it out to Megan. I know it's a part of this issue. The arguments in favor of alarms, and people that have argued for putting them on things like small boats in Florida, for manatees, have been a part of this kind of dynamic too. And people have shown that manatees move away from boats sometimes, but they don't move away from them all the time. And the case of putting alarms on boats doesn't strike me as a compelling one for a variety of reasons. But I'll maybe let Megan add.
I mean, I guess I would agree with that. Putting on alarm, the issue of habituation, and also varied responses. You could have one animal that, well, I know with pingers we know about dinner bells and warning signs, right? So they can interpret that sound as differently. So there's some risk with adding that noise in there. And then the other thing with quiet technology, although it will reduce the noise, I don't think ships will ever be silent. So there's always going to be some noise source. It's just hopefully the technology would lower that. I don't know if John would have anything.
I was just going to, I think Megan highlighted that one avoidance response, but we also had clear evidence in that data of several instances where whales seem to react to the ship by spending more time at the surface, blue whales in particular. So it looked like we had the longest surface periods right after a ship close approach. And that parallels, I was going to bring up the Doug Nowacek study on the East Coast that showed right whales responded to an alarm response by spending more time at the surface. So I think in at least 2 cases, one with blue whales and one with right whales, we have evidence where whales reacted in the opposite way to an alarm sound. Instead of moving away from it, it brought them to the surface where it would make them more vulnerable to ship strikes. So I think we have to understand those reactions much more finely before we might take an action and put alarms that might have the unintended consequence we don't want.
Let me try a totally off the wall question. I'm interested in how you think this soundscape might change with anticipated changes in the ocean over the next century with increasing temperatures and increasing ocean acidification. What effect does that have on the soundscape?
I was wondering if I get that question. I would like to run this with some changes due to acidification. My impression, and I can't even remember how I formed this impression clearly now, but my impression is that acidification is not significant in terms of the sound propagation. And there have been a few papers on that seemed to me somewhat convincing that that wasn't an issue, but we'd like to just rerun it and see. The temperature one I haven't thought about too much. That could be quite significant. It's really hard to know what that would do, whether it would make it louder or quieter without looking at it, because the effects of the temperature structure on the sound propagation are quite complicated. So that's something we should look at. It's actually not an off-the-wall question. It's a good one.
Can I just say something? So, because I get various papers to review, I got some of those, where they're talking about the acidification is going to change the absorption, and that leads to global changes in noise. But it turns out that there's a frequency-dependent absorption, and it's in only the mid-frequencies where the fact that the ocean is getting more acidic that you get less attenuation. So we're talking about sort of 2 to 10 kilohertz. Now, that doesn't have much of an impact at all on global ship noise is really an issue down below about 300 hertz. So it's irrelevant for that. But locally, you could imagine there are a bunch of deep diving animals like sperm whales or beaked whales who have evolved to forage down at depth. And it's reasonably quiet down there because most of the noise is at the ocean surface. So the only place where I could kind of say, well, maybe this might be important, it's nothing at all what the paper said, but it was the fact that surface noise will more readily propagate down to depth. So there may be more noise at depths where things like sperm whales are foraging. But most of what those papers say is, the sky is falling because of increased noise because of acidification is not correct. But if you work really hard, you can maybe think of, one place where it might be significant.
Yeah, in the back there.
We heard a lot today about noises from vessels in transit, and I have a concern of vessels that are not in transit, most specifically to Bay of Los Angeles or LA, where due to Homeland Security now, they've strengthened their inspections, and so ships are now setting outside of Los Angeles to be inspected before they can go into port. And does this have any effect on the migration of the California gray whale? And have you guys looked into that at all, and what type of noise are they producing, even though they're at anchor generators and machinery and stuff like that? Is there any concerns there?
Well, I have an opinion anyway.
No, in our data set, most of those ships are transiting, so if you don't have much knowledge of
We have, we keep a pretty good count of our coastal animals as they, transit back and forth, and we, over, the past decade, see numbers change quite a bit. Of course, we always have our, steady flow of juveniles for protective reasons stay fairly shallow, even having to go through that island of ships that sit outside of Los Angeles. But it's just something that we've been concerned about now for quite some time, and wondering if it's changing their migration pattern and making them more vulnerable to elements and predators because of that.
So Brandon showed a really interesting plot in the luncheon session, and it had to do with this experiment where there was a sound source introduced in the path of the migration. And in the LFA experiment, which was done in, I guess, the 90s, was kind of an echo of an earlier one done in the 80s with an air gun. And what you see is if you put it smack in the path, you know, the whales will deviate around. But the aggregate is that there's a bias in gray whales of wanting to stay in shallow water. Right? In other words, when they put the sound source right on the outer edge, it didn't deflect them. It certainly didn't deflect them out into deeper water. So I think that noises are most significant when they're on the inshore side of where the animals are passing by. So for instance, you know, pile driving I would worry about because, you know, it's obviously in shallow water.
Right.
So and I think this is just a bias of gray whales, that they're more comfortable if they have access to the shallow water. And the sound is kind of, there's a sound between them in the shallow water, then that's more significant than the sound that's outboard. Now, the ships you're talking about are mostly on the outboard side of where the whales are transiting, I think.
Some are and some aren't. So they have a station, well, you can't call it a station, but they have a designated area about 20 miles offshore that they will put a pilot on, and they'll put agents on, and then the boat will be brought in. And depending on what the boat is carrying, the ship is carrying, it may end up anchoring in about 60 feet of water.
But it's not going fast.
No,
it's
it's
not.
not
It doesn't
even-
have the really high sound levels.
No, it would just be anchored there sitting.
Yeah.
And that's what my concern was, is are those anchored ships of any concern as a deterrent? Just minimal amounts of noise.
Yeah, well, it was the kind of 160-ish sound level that you could start to see this deflection. So you
Right.
probably wouldn't get that from an anchored ship.
I was going to address that we've had anchored ships outside of Los Angeles Harbor and off the El Segundo area, and we continue to have a good number of gray whales going through without any seeming deviation toward it or away from it, just pretty much ignoring it coming through. It seems like the levels would be pretty small, but we've been doing whale watching out there for years, and we're not seeing any kind of difference as far as that goes. If anything, we've got some bias toward the rigs when they seem to head toward the oil rigs, come from the oil rigs, maybe perhaps using those even as navigation or something, but as far as the anchored ships, I don't see any difference at all.
Yeah, that's the kind of thing I was interested in. Although these kinds of noises are pretty new, evolutionarily speaking, on the other hand, these animals learn pretty well, some things anyway, and sometimes they've learned to approach ships, certain motors, blah, blah, blah. So the question is, do you have any indication of individual learning about these dangers? It's a steep learning curve, I admit, but do you see anything for individual whales that might be useful to know about?
I would say, and John can probably add to this, though, with the tag work, if there is a reaction, it does seem to be in very close proximity to the ship. So if they are reacting, it's on a very short spatial scale, even though they might be detecting that ship definitely detecting that ship from many miles away. So so maybe that's the learning at the close approach when that threat is right there. But
Yeah, like that kind of thing doesn't look very good from our perspective, but from their perspective, it might be a little different. The way I'm thinking now about crows and gulls and so forth that are busy picking at something on the road, and you'd swear that they ought to get out of there more quickly, but they don't, and they hardly ever get hit. So they have a level of comfort that appears to me to be dangerous, and I think it sometimes is, but somehow they must think they know what they're doing.
I mean, I think the main caveat I would have is that I think there is the potential quite a few blue whales, for example, are getting hit because we suspect it might be 10 times more than the number being discovered or documented. So I'm not sure it's quite as effective as crows.
No, they've got visual too.
Yeah. So.
they're along the shelf edge. They're in the shipping. I mean, they're feeding there. So there's behavioral context, which Brandon
I mean, I think one key point is just to realize that I think probably the different species are very different from each other, and that I suspect that reaction to a close approaching ship is what controls the differential vulnerability of different species. Why some species, blue whales, fin whales, are much more prone to ship strikes than some others.
Yes?
Have you, in your modeling, have you looked at all at other boats, like recreational boats, and their sound impacts?
Yeah, you know, I actually don't know what all the layers are in there, because I guess that's been more between you and Mom.
Yeah, I mean, when we started with the big ones, really. I mean, I think not yet, but realizing that in some places like in Florida where there's 1 million recreational boats, it's probably really important, or places in California, it's really important at certain times of the year especially. But given the, you know, all of the different sources and the scales we were looking at, it was one that we didn't quite get to, right?
Yeah, and there are a number of just data constraints that aren't, in most places, there aren't good spatial data sets on recreational boating. There are some places around the U.S. where people are collecting that data now, but there haven't been good data sets available in the past. And then when you get really close to shore, which is where their activity is most prominent, you need different acoustic modeling techniques from what I understand, and some of that interaction with the shallow bottom makes things more complicated. So we ended up saying that that's important, but not as big a source to the chronic background noise as these big, large ships. And that it probably is going to require a different kind of approach. So it's something that we're thinking about for the future. And there's kind of a whole, the way I said the coastal haze, there's a whole suite of onshore and near offshore activities that happen in the coastal zone that contribute to background noise, including, you know, harbor construction, pile driving, and all of the recreational boating and everything. And most of that we don't have a good spatial representation of it, so you need some kind of model-based approach to sort of estimate where levels are likely to be high.
Did you, Ann?
Both you and Megan have data for every series of hours for a number of animals. Did you come up with evidence that the animals were having a significant interference in the activity of the weather in very little short periods of time?
Yeah, I don't know if people
Could you
hear
repeat the question?
Yeah, the question was basically, you know, the tag data are really looking over periods of hours, and was there evidence of changes over longer periods of time? And I would say, you know, from the BRS kind of experiments or these tags in the ship strike context, you're limited to those windows of time. The responses that we have tended to see in the blue whales have really looked like the animals have gone back to their baseline kinds of conditions within that period of time. But we really don't, that's where that part of it becomes limited, where you've got, you know, a day's worth of data. In the Bahamas beaked whale case, the animal that one of the animals we exposed was still responding afterwards. It was subsequently re-seen in the same area the following year and photo-identified, so you have kind of a longer-term follow-up. But that middle, you know, duration, the longer duration thing, that's I think really where the satellite tag kind of things come in, that give you that longer time duration, and where those things kind of work in combination. So there have been resites, and we've resited some of the animals that we did, blue whales that we did playbacks on, you know, in some cases the next day, in some cases, you know, several months later, I think in several cases the following year. So we have those kind of resites that they seem to be doing normal things at some period of time later. But most of the responses we saw were temporary, even within that period of, you know, 12 hours or 6 hours. Megan, do you want to add anything else to that?
Yeah, I think that it's just, like you said, with the satellite tags can really help get at some of those questions. We were looking at very close approaches to these ships, and sometimes deployments were only 2 hours or 4 hours, and so it's with that data set, it's sometimes challenging to sort of scale that up. If there's like spatial patterns in their movement based on the traffic that goes through there. We do have a couple, I showed the one long example, and we just need to go into more detail, and I think we have 3 of those that we could start looking at those patterns, because we did have satellite tracks also, so.
I wonder, we got about 15 minutes left, and maybe we could take any other questions, but John raised some important points, I think, about the seismic issues, and these are pretty, current and pending issues for California, and I wonder if anybody had, I don't mean to cut off people that had questions, but I thought it would be good if we came back around to maybe discussing some of that, and I wonder if anybody had any comments or questions or anything like that related to any of the seismic issues. Yep.
This might be related. I'm interested in hearing your perspective on the idea of acoustic budgets and on what scale that kind of management approach might be tractable, whether applied to seismic surveys or just ship notes.
John, you've thought about this some. I mean, I've thought about it a little bit. You want to take a first crack at that?
Well, I mean, it's site-specific, right? You say acoustic budget, meaning here's a place and I want to know, what are all of the inputs to just the anthropogenic sound or all the sound?
Oh, that's one of the dimensions of it. I think what I meant was policies about how much noise can be made in an area at any given unit of time.
Yeah. I mean, Brandon, there was the whole effort of going beyond the simple, here's 1 dB, and if you cross that boundary, you're in trouble, and if you don't cross that boundary, we don't care, right? I mean, that's way too simple. And if you're interested in that topic, I mean, the EIS that Brandon did with SMRU, I think was a really good step in that direction. But, we've got to get more specific about the sensitivity of particular sites and the sensitivity of particular animals and, frequency bands and, and all these other metrics that are actually important. So, 1 dB number doesn't do it, but I think lots of people have said that for years now.
And one perspective I would share too is if you set like a cap and trade DB system or something like that, you could box yourself into some corners that you wouldn't necessarily want to be in. Like if you say, here's a certain level, the noise can't be above this for this period of time, therefore let's take this suite of activities and spread it out over a longer period of time. There's a case to be made in certain, and I agree with John, certain cases or situations where it might be better if something is going to go forward, it may be better to have it just go forward and get over with instead of spreading it out. It gets back to this issue about speed and residence time too. You can make a case both ways. I'm not saying I uniformly believe that 10 surveys should happen in Baffin Bay and Greenland at the same time and amplify everything for 2 months at a time and nothing else the rest of the year. But for instance, with the work that we did off in Southall with the gray whale advisory panel, we were working with the company that was doing the seismic survey, and arguably having a seismic survey happen in the middle of critical feeding habitat for critically endangered species might not be the best thing to happen, period. But given the fact that some of this was going to go forward, one of the arguments of when do you do it and how do you do it and do you allow nighttime shooting and all of these things, the overriding kind of principle within the IUCN panel was get there as soon as you can. When the ice clears, get it done, get it over with, and get out, because if you stretch it out, you're kind of extending the disturbance. So, I mean, I don't think that, I'm not saying necessarily that some type of spatial temporal budgeting kind of consideration is wrong, but if you just set really kind of blanket rules, you could box yourself into doing things that you wouldn't want to do.
So I want to get back to your, you threw me a pass or whatever, so I'm going to catch that. Now the thing about, so here we are in Southern California, this is the focus of this meeting, and one of the most sensitive habitats for us in terms of marine mammals is the Santa Barbara Channel in Point Conception. I mean, we know that there's a really high density of animals. Already we have a lot of shipping noise. now along comes seismics. And, you know, we've been blessed in many ways that even though there's producing oil fields there've been no seismics for a long time. So I think as a community, we need to get our brains around how will, you know, in anticipation of that happening again, if it is gonna happen again, how should we be ready to monitor the impact it might have on this fairly sensitive habitat? So.
Right, and you know, and one of the things that came up in the lead up to the PG&E work was there's no baseline period. There's no baseline data during the period of time when you're supposed to be observing.
Right.
And the problem with a lot of these kind of exploration surveys and studies is people just want to look at what's happening during it. And you know, without that sufficient kind of baseline and the amount of time that it takes to really do that right and have some idea of the variance, it's way ahead.
Yeah, well, so let's throw it back on, you know, it's always the government's fault or whatever, but, you know, so minerals management, whatever they're called now, right? You know, it's their responsibility to sort of regulate. I mean, they collect fees from the oil companies and they're supposed to regulate that activity. And my fear is that one day I'll be sitting at my desk and I'll get this EIR that says they're going to do massive seismics in Santa Barbara, and it's going to happen next month, right? I mean, this is kind of what happened with us. It wasn't quite that bad, but almost on the PG&E stuff. I mean,
Right, but like John's point off of
Yeah.
Washington, this happened.
Yeah.
Right? It happened with very few people knowing about it.
Right. So it seems like maybe as a community, if we could go to BOEM and say, you know, if you have any thought of restarting seismics in this area, years in advance, you better, you know, provide us with a mechanism to get ready. For instance, I don't know if there's a BOEM person here in the audience. We can all.
Follow up, I know I've already heard both you guys on this. As computer scientists and mathematicians, we might be doing some of the acoustics work there on some of these things someday. It would sure be nice to have a standardized process that we follow. So creating workshops to teach the computer world and the biologists and such to do this in a standardized way might be a good idea. Those of you who have already done it.
Sorry, to do what in a standardized way? You're talking about the data
Some of
collection?
the EIS work, to do some of the acoustics modeling of seismic guns, that sort of thing. There's any number of ways to do it out there right now. I was up at the Alaska Marine Symposium and listened to a talk about someone doing it completely another way. And so it might be nice if we're going to do it here in California, and it's going to happen. It might be nice just to have the way so the way we should do the mathematics, the way we should do the acoustics modeling of seismic guns going on. And then how the associated harassment rate estimates and how that happens and the time of day and all the other variables and coefficients that go into that.
I agree.
Greg?
I just wanted to follow up on what Don was saying. I think it's important to include academics as well as industry, because if I recall correctly, the one off the Washington coast wasn't something that mineral management was development control, that was academic. That even goes back to the news.
Yeah, Tom?
Yeah, I just want to address the issue of finding what a baseline is, because none of these animals, I mean, none of them are naive anymore. Maybe in California, some of them have been exposed, you know, with population of species like that. But most species, migratory ones, have been exposed to air guns, let's say, or seismics, in migratory areas. So when you're talking about baseline, it's really difficult sometimes to define what baseline is, because there's so many different potential or existing noise impacts. So I don't know, just kind of throwing that out there, like you need to define what it is, what your question is first, I think, and what time scale, because it's such a nebulous issue.
Well, I agree. I mean, I guess a start would be having some, you know, survey data at all in the area where an activity is gonna happen. I mean, in that case of, literally of the you know, November, December, off of those areas of Morro Bay, most of the you know, there's just a complete lack. I mean, sort of looking at John, right? I mean, there's a complete lack of visual or aerial survey data or baseline acoustic data for species presence or absence in those areas. I mean, I'm just saying, some of, further to John's point, being ready for some of these things. I mean, I agree with Tom, but, you know, some of these areas, we're talking about complete lack of the basic information that you would use to say, do you expect animals to be in that area at all during these periods of the year?
Well, I mean, I think there's the, you know, the Southwest Fisheries Science Center survey data that's collected every 5 years, and I mean, are excellent surveys to estimate abundance West Coast wide, but they're not designed for intensive coverage of a localized area where you might be interested in a very specific impact. So, you know, there is kind of good data in a general sense, but often missing on a very specific and specific geographic region, which would often be the focus of something like an air gun survey like there was on.
Right.
You know,
and even those, and maybe I'll look at Barb and correct me if I'm wrong, but I mean, the broad scale surveys have recently found their own difficulties in happening, and you know, having some of that being on a downward trend when some of these other things may be on an upward trend is a dangerous combination, right?
Right. Yeah, Brandon's right there. I mean, we just went through a review with the Marine Mammal Commission, and it looked at our number of ship days for the past 20 years, and you know, we went from about 240 days a year on average to 0 starting about 3 years ago. So that's doing surveys with big ships is a real problem. We all know the dangers of doing surveys with airplanes. It's a real problem. You know, so it is something that I think the community needs to find some ways to identify the areas I think that are most vulnerable, and to get, we've never had good seasonal coverage. And so, you know, when those tests came out to test the John Paul Jones or whatever that ship was, I mean, that took a couple of years of survey work, of doing seasonal survey work over in a large area to sort of identify it. You know, it is on these sort of emergency bases, and, you know, maybe the thing to do in this case is, you know, to sort of throw down the gauntlet, you know, write a paper and say, if you want us to be able to respond to this is really the amount of effort that needs to go in before we can give you a reasonable interpretation of anticipated impact, and we just simply don't have those data at hand, because we don't. We really don't, especially for outside of the, you know, our typical survey window, which is like July to October. I mean, outside of that window, you know, other than, you know, HARP data or something, I mean, for small cetaceans in particular, we're pretty cool.
I argue there is some new data. I mean, for 5 years of surveying in SoCal, we've got like 20,000 nautical miles of coverage. And for the past couple of years, most of the aerial stuff we're doing has been in the wintertime, to the point where we're getting ready to publish density on it. So, but it's not Santa Barbara Channel, but it is, you know, you would expect the assemblage in that area would be probably similar to the assemblage in Santa Barbara, but you don't know.
Also, just point out, for the last 8 years, SIO with Cascadia has been conducting line transect marine animal visual surveys on Calcopy surveys, which are 4 times a year, so they cover the quarterly surveys. So there is data available that documents presence, absence, all the way up to San Francisco in the winter and spring periods of these species. So, you know, perhaps there's a value in looking broader, or in a broader scope of what data perhaps is available out there.
Can I
Monica?
add
Go
something
ahead,
just real quick? Just a plug for the work of the other half of this NOAA effort. There was the sound group, and then there was the cetacean density mapping group. And their goal was really to try to pull all of the existing survey and habitat mapping data together in a one-stop shop. So if Yvonne Paris and a bunch of people from the Southwest Lab were involved, and if you go to the same website that Brandon mentioned earlier, setsound.noaa.gov, you can find what's available, and we can kind of answer this question about where the gaps are, because they've they've organized it by quality of data and by month of the year. So you can see when the surveys happen, whether they're just presence absence or there's some habitat modeling that's gone in to predict where species would be found and what kind of abundances. So that's all.
And I think we're coming up to the end. Maybe we'll go with two more points. Yeah.
Cool. I was going to play devil's advocate here. So far, you know, we're looking at ship noise. We just look at the chronic ship noise problem and baleen whales that are potentially responding to it. And a lot of those species have been increasing in populations for since the 60s or whatever. Do you see, you know, right now perhaps you could say this is not the main problem addressing these animals in a lot of cases because it's not clearly like a direct threat. Do you think that there's some threshold in the future as the economy increases and shipping increases where that shipping noise comes from kind of more of a nuisance or whatever to something that can really be detrimental to you know, overall populations?
John, you've sort of tackled this issue before.
Let me take issue with your...
I said, I prefaced that with playing devil's advocate, so
Yeah,
I'm not saying that's my opinion, but...
Because we take blue whales.
Right.
The surveys, the NIMS surveys from the 90s have about 2,000 animals, and the NIMS surveys from recently have about 500 to 600 animals.
Mm-hmm.
So how can you say that they're increasing?
Okay.
Or that they're doing okay?
Right.
Well, you could argue that the surveys aren't catching all the population because we have data showing that.
Right.
The survey techniques are getting better, so why would the numbers be dropping?
Yeah, well, there are some people in the room that can comment on this. I'm just throwing out this, but you know, you made the bold statement that
right.
blue whales are doing fine.
Okay, maybe not blue whales, but humpback whales are increasing.
They're also getting hit by ships.
Yeah. I mean, a lot of baleen whales are increasing in population. Not all of them, but some of them are.
I mean, you could just this. I'm not saying this is true, but you could say that maybe because of the ship noise in the area where the survey is done, it's displacing the animals from areas where they traditionally have been.
Right.
Right. So I just don't think you can say, you know, baleen whales are doing great, noise is going up, therefore noise is either good or it does nothing.
Right. Yeah. No, I agree with you. I was just wondering if anyone's done any simulations where we see, you know, there's some threshold that gets crossed as sound exposure levels increase to, I mean, right now, I mean, we don't know right now how much of a problem it is on their overall health. We know very little, but do we know that if it increases by, say, another 10 or 15 dB, that it really would be detrimental? Has there been any sort of thought about that, or before we start laying regulation on what sound, you know, laws for sound pressure levels and all this other stuff, is there any consensus on what would be, you know, achievable and or if we pass that, detrimental to the animals?
No. In terms of consensus, I don't know, but I mean, there's there's Chris's work on acoustic masking and in places like off of Boston Harbor, like I showed, where the traffic is so continuous that it's got to be getting to the point where it's cutting into the animals' energy budget because they don't have the ability to forage as effectively. But actually making those links from those sublethal effects that are subtle behavioral displacement things to consequences for the population as a whole is really difficult. Brandon referred to the PCAD modeling effort. That's an attempt to try to take those sublethal effects and build them into a population dynamic model and make that link. It's just really hard to do.
And I think that's a really important effort. I think if people think we're going to get to a point where you're going to say here's a threshold and you go beyond this and you're going to see a measurable, I mean, if a measurable population level effect is the point where we've reached some tipping point, we've waited too long.
Waited too long,
you know.
Agreed.
And so I think it's dangerous to try to think of something that would get there.
Mm-hmm.
But short of, I mean, once you open Pandora's box and say we're going to do something other than 160, 180, it does get hard because it's sort of, these things they depend and they're context dependent and all of those things. That's why I think something that's more like a risk framework methodology makes a lot more sense than trying to draw these lines. And maybe, I see in Tennyson stand up here, we're about 20 past, so maybe we'll, and then Monica, you're waving emphatically.
Well, it's not very often you correct on Hildebrand, so I just wanted to. But you kept saying that there's no seismic activity going on in California, and that's actually not correct. I mean, there is seismic work going on of California, which made me think that that noise that potentially you're hearing might actually be a 2D survey, not a 3D survey, which was proposed by PG&E. Steve Jeffries and I were joking that it sounded quite automated, and unless the squid fishermen have now developed some sort of automated, you know.
So I know air guns, and they're not, those are not air guns, because among other things, it's not regular. If you looked at the timing, I mean, that one, there was a lot of them, but it was, 3 seconds and 5 seconds and 10 seconds, and it wasn't a regular, like a seismic survey is, there's a rep rate, boom, boom, boom.
It sounded boom, 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 but
But
anyway,
it's
long
not.
story short, there is seismic stuff going on.
That's permitted?
Because it's 2D and it's a particular level, there is no permit per se.
There's no permit?
No permit required.
So where are these done?
All over.
2D seismic surveys are being conducted with no permits.
By
who?
Various sources, USGS is doing some, they contract out.
Yeah, but I know the USGS surveys, right, and those are not large scale.
No, they're not large
They're
scale.
just little.
But I didn't want to give the impression to the community that nothing's going on besides what was
Right.
introduced by PG&E.
No, and I think the distinction is, so there's an industry scale of arrays of air guns, and then there's somebody who goes out with, one air gun or something. So
They're a little bit bigger than one air gun, but yeah.
there's a difference in the scale though. But the stuff I played for you and all of those shots at Tanner Bank, those are not air guns.
All right, I think I'd like to thank the panel. I really appreciate this.